In July 2021, Amazon founder Jeff Bezos' aerospace company Blue Origin launched its first trip for space tourists. On board was the controversial entrepreneur himself.
This is incredible.
Oh, I love it! I love it!
The flight lasted about 10 minutes. The rocket shot up over 100 kilometers, high enough for passengers to experience weightlessness. 9 days earlier, British billionaire Richard Branson had also launched into space with his spaceflight company, Virgin Galactic.
Woo!
The world's first commercial space flights, shuttling tourists to the edge of Earth's atmosphere and the beginning of a new era in space. Imagine for a moment it's the year 2028. A European lunar lander has just reached the moon's south pole, where it's deployed several rovers. Their job is to map the area, then collect and analyze samples. Legwork that's important to this exploratory mission. Within just a few months, astronauts from NASA, the European Space Agency, and private companies will touch down here. Technology hasn't come this far, yet. But experts believe scenarios like this one could soon be reality. One thing's certain, a new space race has begun.
My name is Armin Wedler. I'm from the German Aerospace Center in the Institute of Robotics and Mechatronics, and we're here at the Arches demonstration mission.
In June 2022, Armin Wedler and more than 50 international scientists conducted research on Sicily's Mount Etna.
We're demonstrating how we could use robots to support a space settlement, say a permanent base on the moon, and how we'd conduct scientific exploratory tasks. This is our Arches base camp with 4 22-foot containers. We have 3 control rooms and a living container. Up ahead is our communications container. A few colleagues are still adjusting some settings.
Researchers from the German Aerospace Center spent 5 years preparing for this mission.
Down there, you can see the exploration camp where we're carrying out the mission. That's where the lander is. We have to walk 250 meters every day, with a 70-meter change in altitude. So, seeing as we're at an altitude of 2,600 meters, colleagues are always panting on their way down.
Volcanic rock is fresh earth, untouched by erosive forces. It's the Earth landscape that most closely mimics the surface of a faraway planet.
Mount Etna is well suited for Mars and lunar exploration missions. And because we're running a technical test of our systems, it's especially important to have this fine granular dust, this abrasive material. That way, our technical systems are truly getting exposed to the elements and have to withstand them. In this scenario, the lander has touched down on the planet's surface. So that's why we only really have an observation control center here.
The team arrived 2 weeks ago to test out the rover's ability to navigate extremely dusty terrain. Their goal? To map and survey a 250,000 square meter area on Etna's surface. In order for humans to survive on other planets one day, scientific missions like these need to succeed. More than 6 decades ago, government space agencies started sending people into space. On July the 16th, 1969, Apollo 11 launched from NASA's Kennedy Space Center. Spectators were enraptured. Who would be the first to land a person on the moon? 4 days later, some 650 million people around the world were glued to their televisions as the news came in. The United States had won the race.
It's one small step for man, one giant leap for mankind.
But just a few years later, in 1972, NASA discontinued its crewed missions to the moon for reasons of cost. To date, only 12 people have set foot on the moon. May the 30th, 2020 was another day that went down in history. American astronauts Bob Behnken and Douglas Hurley launched from Cape Canaveral, heading for the International Space Station, the ISS. This mission was special. For the first time in the history of space travel, the capsule transporting the two men had not been developed and built by a government space agency. Rather, it came from a private company. And marked the start of a new era for government agencies like NASA in the United States.
My name is Phil McAllister, and I'm the Director of Commercial Space at NASA headquarters. Right now, what we're seeing is in space, there's just a tremendous amount of opportunity, but nobody's exactly sure what's going to be the real moneymaker. Obviously, we are seeing transportation. We're seeing people make money at that. But then when they get into space, what can they do? What are things that are really going to make money? And I don't think anybody knows for certain what that's going to be. It's just their first step to doing more and bolder things. So I think the companies that are offering this capability today, Virgin Galactic, Blue Origin, SpaceX, this is just the first step to a larger, grander vision of what they want to accomplish.
Commercial space companies say making Mars habitable for humans is one of their goals. An outspoken champion of this concept is SpaceX owner Elon Musk. The controversial billionaire has played an outsized role in triggering the current space boom.
There are really two fundamental paths. History is going to bifurcate along two directions. One path is we stay on Earth forever, and then there will be some eventual extinction event. I don't have an immediate doomsday prophecy, but it's eventually, history suggests there will be some doomsday event. The alternative is to become a spacefaring civilization and a multi-planet species, which I hope you would agree that is the right way to go.
According to Musk, saving humanity begins with traveling to Mars. So SpaceX wants to send crewed flights to the Red Planet before the end of this decade, and even start building human settlements there.
From a purely geophysical perspective, I think he's right. It's only a matter of time before the next major catastrophe will strike Earth.
But an important question remains. How will all these ideas work in practice?
My name is Christiane Heinecke. I'm a researcher at the Center of Applied Space Technology and Microgravity. My research focus is habitation, the question of how humans can survive on the Moon, Mars, and other celestial bodies.
Christiane Heinecke has real-world experience trying to answer this question. She spent 366 days on Mars, not the real one, of course, but a spot on Earth with a similar terrain, the volcano Mauna Loa on the island of Hawaii. There, she and 5 other scientists from different countries lived together as part of NASA's High Seas experiment. Communication with the outside world was only possible via email and, as would be true on the real Mars, with a time delay. Venturing outside was only permitted with a spacesuit, but even a simulation like this one only scratches the surface of the challenges living on Mars would present.
This habitat was primarily aimed at psychological studies. It was quite fancy, kind of like what you'd imagine on Mars, a beautiful white dome in a Mars-like landscape. But when it comes to the technicalities, this habitat wasn't very realistic. And if we actually wanted to fly to Mars or the Moon, we'd need a habitat that was fully operational. Something that would really work.
That's why Christiane Heinecke is collaborating with architects, engineers and psychologists to build a habitat for space. The project is called Moon and Mars Base Analog, or MAMBA for short. This is what it could look like one day.
Das Mamba-Habitat, das besteht insgesamt aus 6 Modulen.
The MAMBA habitat is made up of 6 modules. There are upright cylinders arranged in 2 rows. Here is the hub of the station, the laboratory module. Then to this side, we have a workshop, because things are sure to break. And here we have a greenhouse.
Das Gewächshaus.
And behind that, in the second row, we have the module for living. Here again we have upright cylinders. These are connected to one another. And then we have a module for sleeping. Then a kitchen module, because we have to eat somewhere. And then we have a leisure module. And then I have airlocks on each side. There are 2, for the simple reason that if one breaks, the crew can still get out. And this entire habitat is under a big dome made from loose dust and rocks. We use moon rocks to protect the habitat from radiation.
But the development is still in the early stages. Fundamental questions remain unanswered. How would the life support system work? How would the interface and equipment work so that everyone could operate them? What is the ideal ceiling height? Christiane Heinecke and her team have built a life-size wooden model of the laboratory module to try and work out questions like these.
Mamba is ein Habitatkonzept, mit dem es möglich ist.
MAMBA is a habitat concept designed to make it possible to fly to the moon and actually live there. But MAMBA should also be a habitat where people feel comfortable inside. We're the only ones investigating the question of how to construct a habitat that's technically functional, and then actually building and testing it.
It could take 20 years before a station like MAMBA can be built in space, but these findings from Bremen, Germany could be put to immediate use here on Earth.
What we need to survive on Mars are the same things we can use here on Earth. I need a system that cleans the air and recycles it. I need a system that cleans the water and recycles it. If we were to learn a thing or two from Mars, then we could live sustainably here on Earth too.
The arduous journey to Mars also poses major challenges for researchers. Then, the red planet's atmosphere leaves humans exposed to deadly cosmic radiation. And the problems just get more difficult from there.
My name is Stan Odenwald. I'm an astronomer. I work here at NASA, Goddard Space Flight Center. If we want to go to Mars, we have to learn how to work in an environment that is very unfriendly, where we literally have to bring our own atmosphere, our own resources, and the best way that we could actually understand how to work in that environment is to work in a nearby environment that's not that different. And that happens to be the lunar surface.
So the world's major space agencies tend to look to the moon these days. Many wish to repeat the success of the Apollo landing. The reason is simple: proximity. The distance from Earth to the Moon is, on average, 384,000 kilometers. That's about 30 times the Earth's diameter. Depending on its position in orbit, Mars is between 56 and 400 million kilometers away. In the best-case scenario, the journey to the red planet would take 6 months. For that reason alone, the Moon comes cheaper from a purely economical standpoint. The trip takes just 3 days and requires a fraction of the fuel. A shuttle service between Earth and the Moon might even be feasible, thanks to advances in aerospace technology. The Arches mission carried out on Mount Etna in 2022 is one of many that help researchers better understand the Moon. Here, the team is testing rover prototype LRU-2, designed to explore unfamiliar and difficult-to-access terrain. The rover navigates autonomously, identifying objects of interest and collecting samples.
Just give 1 centimeter more and let's try again.
This task is especially delicate. The LRU-2 should deploy a laser module to analyze the surface samples it has collected. So far, the task has never been carried out successfully.
If it doesn't work and the arm crashes into the cameras, we'll have to start all over.
Yeah, it's placed. Looks good. Ah, yeah, it's moving back. Yes. Oh, thermal shutdown. Yeah, the arm went into thermal shutdown.
Another failure. That's how it goes in scientific research. Some days it works, some days it doesn't.
When you stand down here all day waiting for something to work, and then finally it's just about to work, and then there's some error again, and then it starts all over again, well, that can be a bit demotivating. When you're always standing here waiting, and now something works, and then the next error pops up again. But yeah, step by step.
Step by step.
Test missions like these cost millions and have no direct financial benefit, a risk most profit-driven companies would never take.
Without these technologies, without this development that you see here, commercial ventures wouldn't exist at all. They're based on these advancements in knowledge. And it often happens that people train here, then end up working in commercial institutes.
SpaceX may be sending the rockets, but the technology required for space exploration is developed at the expense of the state. 2021 marked a record year of government spending on space programs, and that investment is only growing. China is pouring money into space exploration, and it's emerging as a new big player among the traditional space powers. A Chinese rover is investigating the largely unexplored far side of the Moon, and it's already sent samples back to Earth. Another rover reached Mars and has now transmitted selfies and sound files. China is also building its own space station.
The reasons for the station are simple. First, our technology is ready. Second, we want to be a strong space nation. Therefore, we need to expand our potential to send people into space. We need to venture deeper into space so that we can use space peacefully.
Parts of the Chinese space station are already in orbit, and the first taikonauts, a term used for Chinese astronauts, have already visited. In March 2021, China signed a memorandum of understanding with Russia's space agency, Roscosmos, to build a joint lunar station. The global race to the Moon is in full swing once again.
Yeah, there might be a little bit of a race, right? Who is going to establish the values and the framework of how we're going to operate in space? I think we would like those values to reflect our current values here in the United States, and to be able to do that, You need to be able to be out there.
There are some states that share knowledge openly. There are other states that are very, very secretive about what they're doing, why they're doing it, and the results. So I think there's always going to be a tension between these two.
Das macht mir große Sorgen und da glaube ich müssen wir als Europäer.
I'm very concerned about this. I think we as Europeans absolutely must be prepared to act, or else we'll miss the boat.
An uns vorbei.
Why are humans so fascinated by space in the first place? To date, some 600 men and women have actually traveled to space. We asked one of them.
My name is Kayla Barron. I'm an active duty naval officer, a submarine warfare officer, and a NASA astronaut.
Kayla Barron was the 601st person in space. She spent 176 days on the International Space Station.
It's incredible. It's actually pretty hard to describe. There's just so many exciting moments, whether that's launch, re-entry, spacewalks, robotic operations, science campaigns. It's a humbling experience and a huge privilege to be a part of the team. When I first floated into the space station, I think I was just overwhelmed by the visual experience because we use every surface, but the space station is just packed with stuff, computers, cables. It took a while for my brain to understand, what was useful information that I needed to pay attention to and what was sort of the background visual clutter. It kind of gives you a sense of how big the structure is. These are the modules that we actually are living and working inside. So when you see video from us inside, we're inside these pressurized modules. But then you can also see the unpressurized section of the space station, this huge truss that primarily supports the solar arrays and our radiators. So that's how we get power and get rid of heat. But it's big. And I think you especially get an appreciation for that when you go outside to work on it.
And Kayla Barron did just that. Twice, in fact. Each time she worked for about 7 hours. Just 3 millimeters of spacesuit separated her from the rest of the universe.
When you look out the window, these views are incredible, but you're looking out a window. And there's something about being in a spacesuit that's really cool because when you look out your visor, there's nothing in your peripheral vision. And so you really are like, I'm out in the vacuum of space in this tiny spacesuit on this tiny thing on this giant space station, just zooming around the planet. When you look up and take in those incredible views, it just takes your breath away.
Many astronauts who have seen Earth from this extraordinary perspective describe the experience as transformative.
Seeing the planet from that perspective changes everybody. The first time I looked at the Earth, seeing it as this interconnected organisms with all of these different ecosystems, all of these different species living all over the planet, I think it really made me, as an individual human being, feel like I was a steward of the planet. You just feel really amazed that Earth even exists and that we get to exist on it. I think going to space really sparks this childlike wonder. You discover the world all over again, living in this unique environment, floating around, getting to play with water in space. I think we all felt like kids a lot of the time. When you get to space, you have to learn how to move around again, how to go to the bathroom, how to eat, how to get water, like all of these things that we take for granted in our day-to-day adult lives down here. You have to relearn up there. So yeah, definitely made me feel like a kid again in a lot of ways.
The International Space Station has been orbiting some 400 kilometers above the Earth for more than 20 years. Its retirement is planned for the end of 2030, although the exact date has not yet been determined. The experience of living in space is something private aerospace companies now want to offer to many more people for a price. A private company in Houston, Texas is one of them.
I'm Matt Ondler. I'm the Chief Technology Officer for Axiom Space. Axiom Space's primary business model is to build the first commercial space station, which is incredibly complicated.
The concept is clever. The basic idea is to utilize the infrastructure of the ISS, gradually docking 4 new modules onto it.
It is more of its own station, but we're able to leverage certain resources on the ISS. For example, we'll get power from the ISS early, so it makes it easier to build a space station when you're building it off of the ISS. It's like going camping, but you got running water and electricity. This is our entire station, the first 2 modules, plus the 3rd module, which is dedicated to research and manufacturing, and then the power thermal module. The Earth Observatory. These are the largest space windows ever attempted. They're about 2 meters by 1 meter. That's where all the Instagram pictures will be taken, is from the Earth Observatory.
NASA is supporting this project with $140 million US. What they're building is essentially a highly exclusive space hotel.
Here's a mock-up of our crew quarters. So this is where the astronaut will sleep, get some private time. They have a window that looks at the Earth, which will be pretty amazing. And then, of course, they have a infotainment center where they can monitor the station. Important to be able to kind of get away from the rest of the crew every once in a while. I always say that the inside of the International Space Station looks like a crazy person's garage. There's just stuff everywhere. And some of that is because it's evolved over many years and it wasn't always planned to be how it is now. We're a little beyond that, where we're leveraging a lot of experience from the ISS. So we will be able to build our commercial space station for 1/100th the cost of what it took to build the ISS. We're not trying to solve science problems. We're not trying to solve technology problems. It's really an engineering problem. And so when you're solving engineering problems, it's a lot less costly to do than if you're trying to break through on some fundamental physics.
Axiom Space already completed 1 mission. In April 2022, 3 investors were sent into space, along with former NASA astronaut Michael Lopez Alegria. The estimated price for a single ticket, $55 million US. While there, the private astronauts carried out a set of experiments that might not have otherwise been possible. But not everything ran seamlessly.
There
were moments that surprised me. What we said in our feedback was for future private missions, some things will need to be modified. I'll put it that way. They could only carry out their experiments with our help, which meant we sacrificed our working time to help with their experiments.
There was a lot of learning and figuring things out on both sides and a long process. We're seeing a lot more countries interested in flying country astronauts. So I think our station will be filled with a mix of country astronauts. There might be astronauts from particular companies. And then we hope, too, that we're the place where NASA sends its astronauts to do work, too.
If you look historically, since the beginning of the space age, probably about 500 people have flown to space. About 95% of them have been government employees. I think going forward, it's going to be an order of magnitude more, like 5,000, and the vast majority of them are going to be private citizens as opposed to government employees. And this is the start of that right now. In 20 years, we're going to look back historically at this time that you and I are living in right now and said, yeah, that was the turning point. That's when things really started to change.
If you're a hammer, you tend to see everything as a nail. You know, if you're working in the commercial sector, you see everything as a profit line. And I think that if that sensibility of space exploration as a business endeavor becomes the dominant theme rather than scientific exploration, then I think we have problems.
Missions to Mars and private space stations receive a lot of attention, but the space world's main activity is not quite so glamorous. placing satellites in space. The biggest undertakings are Starlink and OneWeb. Both are designed to encircle Earth and deliver low-cost satellite internet. Another project is Europe's navigation satellite system Galileo. These satellites are permanently orbiting the Earth and delivering navigation data. There are about 5,700 active satellites circling the Earth right now. Twice that number are retired and have become space debris. When it comes to basic rocket propulsion, little has changed since the mid-20th century. There are two technologies: solid propellant engines and liquid propellant engines. In solid propellant systems, the propellant is a solid mass in the engine. In liquid propellant systems, the propellant is a liquid outside the engine. Once ignited, the reaction of a solid rocket cannot be stopped. Similar to fireworks on New Year's Eve. In the liquid propellant engine, chemical components are carried in separate tanks and delivered to the actual engine. This allows for thrust regulation, meaning that the drive can be controlled during flight. The best performing propellant is made by combining liquid hydrogen and liquid oxygen. The legendary Space Shuttle combined solid and liquid propellants. The two white solid rocket boosters on the rim powered most of the starting thrust. Once airborne, they were jettisoned, and continued flight was taken over by liquid propulsion. The catch is, liquid rockets are more expensive, more complex, and more prone to failure than solid propellant rockets. And for many decades, they were only suited for one-time use.
It's like taking an airplane, a 737, and flying it from New York to California one time and then dropping it in the ocean. It makes no economic sense. Nobody would be able to afford a plane ticket if you did that every single time. But that's what we were doing in the space industry. We knew it wasn't the best way, and we knew eventually reusability was going to make a big impact.
Private enterprises needed to make liquid propellant rockets reusable. In 2015, one company succeeded: SpaceX.
What SpaceX was able to do was get reusability to the point where they could quickly and easily and cost-effectively turn around their hardware and fly it again. And that brought the cost down dramatically.
For financial reasons, SpaceX and Blue Origin are counting on reusability. Their modern rockets return to Earth after launch, then stand by for takeoff on another day. To achieve this, there needs to be a pilotable rocket, reusable propulsion technology, and the guarantee of a safe landing. The cost of transporting a kilogram of cargo into low Earth orbit has been drastically reduced by these innovations.
That has been a major accomplishment that has shown that the private sector is mature enough to take on some of the challenges of going into space, working in space, and actually turning a profit from it. I think the profit motive is a big incentive for progressing faster, deeper into space. And I'm glad that they have finally taken interest in this.
I myself have flown with a private provider, with SpaceX in a recycled rocket. And it was a good feeling for me, knowing that the rocket flies up, lands again, and will be reused, instead of becoming space debris. Afterwards, my colleague Samantha Cristoforetti came up to the space station with the exact same rocket that I had gone up in. I think that's terrific. This is the right path.
But the most extensive research is still primarily conducted by government agencies like NASA, the European Space Agency, or the German Aerospace Centre. like here on Mount Etna with the Ardea research drone.
If we look at Ardea, you can see here that we have a total of 4 cameras, each forming 2 stereo pairs. And with that, it can perceive great depth. It flies with only camera systems and IMU sensors. IMU is accelerometers, gyroscopes. It's kind of like the inner ear in humans. So with Ardea, we can not only conduct planetary exploration on the surface, but we can also fly into lava caves and explore other caves as well.
Markus Müller and his team have been working on this technology for more than a decade. Their drone models the environment in real time, offering 3D visibility.
This is essentially the brain of Ardea. It contains all the computational components and the cameras, so it's kind of the eyes of Ardea. And on the other side here we have the propulsion system, the drive system of Ardea. The rotors are still on. If we were on the moon now, we wouldn't have any air there. That means we would need a different propulsion system, and we'd use jets, and that's how we'd move.
A system like Ardea works without GPS, instead utilizing its own measurement sensors. The goal is for drones to one day navigate other planets autonomously and map their surfaces. Here on Mount Etna, the drone is deployed to study the terrain. But what initially worked well is now acting up. The team is trying to get the drone to fly again, but so far without any luck.
The problem is that we flew once, and it happens every now and then that we see slight anomalies and that the copter goes slightly into the pitch, so it makes almost a 45 to 50 degree pitch turn and then crashes.
The cause is simple. The wind is just too strong.
The wind speed here is well over 10 meters per second on average, and the gusts are well over 30 meters per second, and the system just isn't designed for that.
For now, the researchers have no choice but to take their measurements from the ground. It's a frustrating compromise.
So you can go higher, right? Yeah.
There's still a long way to go and an extraordinary amount of effort needed before the technology can be deployed in space.
We're here to explore and advance technologies. Our vision is that we can achieve more by using heterogeneous robots, different types of robots, than we can with just one system. We believe that combining robots with different skills, we can solve the tasks better. It's like when different people work together, engineers, scientists, and technicians.
Technologies still being tested for future space missions. But some are already thinking beyond that.
My name is Matthias Link. I'm the director of the Luxembourg Space Agency, LSA, and I've been involved in the development of the space sector here in Luxembourg for many years.
The small country was once one of the world's largest producers of steel. Today, Luxembourg is a driving player behind a new idea: space mining.
In principle, all resources exist in space. Everything you find on Earth, you can also find in space. That means if humans expand out into the solar system, to the Moon, later to Mars, and maybe at some point even further, it just makes sense that you use the local resources.
One possible target: meteorites containing platinum and gold. The Moon contains rare minerals. It also has frozen water that could be used to produce fuel and breathable air. Then there are the so-called M-type asteroids. These contain precious raw materials that could, in turn, be used in future space projects. For now, the resources in space seem infinite.
Most of the science fiction stories I read in high school and middle school were all about, families that bought their own rocket and went up to the asteroid belt and mined and, did stuff like that. I think it's kind of cool, but the problem is that it's not like those resources are going to come back to the Earth.
It all sounds like science fiction at first. It's really more of a long-term endeavor and will happen on a relatively small scale. Let's say in the next 10 years. Then, bit by bit, it will continue. In the coming decades, new markets will emerge.
The search for space resources could become a booming business. In 2017, Luxembourg adopted a legal framework to mine raw materials in space, becoming only the second country after the United States to do so. The hope is this will enable exclusive access to this new potential market.
No
one owns outer space, but it gets murky when it comes to the resources out there. If you fly to the moon and take a rock and process it, or you drill for water and use it, things start to get complicated. This means we absolutely need an international framework that can effectively usher in these technical advancements and can repeatedly be modified as needed. It's quite clear that a single Luxembourg law cannot be the solution.
The European Space Agency has also become involved. In the near future, the agency hopes to study and extract raw lunar materials.
So that's like a joystick, so you click on it with the mouse.
A gold rush could be on the horizon, and a new era of commercialism in space. Will Europe be part of the race?
Europe is, on the one hand, a leader in space. When it comes to satellites, Earth observation, and navigation, we have very strong programs. But in the field of exploration and astronautics, we're always in the shadow of NASA. I think Europe has to be braver. We shouldn't let this new space development, which we see in the United States, pass us by. If we act, Europe can also be world-class.